Okay, calculus, let's talk about an ellipse. It's the set of all points whose combined distance from two foci are constant. It really looks like an oval. Something like this. So it has two foci, which are on either side of the center. And any point on there, if you add the distance to each of the foci, they all add up to the same thing. In some ways, it's like a circle, but a circle or the two foci are in one exact place in the center, so everything's exactly equal distance. So the ellipse equation looks like the equation of a circle, in that it's x minus h squared and y minus k squared, but instead of being equal to r squared, they can have different lengths. So, and you set it equal to 1, so you divide by a squared and b squared. Now technically, there are two axes on an ellipse. The major axis looks like the longer side. So in this picture, it would be the left to right side because it goes out further on the left and right. How do you know which side goes further? It depends which of these denominators is bigger. The bigger number you divide by, the further you can go out before you become too big. The minor axis is the shorter side. Now the foci lie c units on either side from the center, where c squared equals, you really take the longer side minus the shorter side, but you can use the absolute value here, and they always go out in the major axis direction, which means that if you can go further left and right, that means your foci go out left and right. If your little oval, your ellipse, is taller than it is wide, you must go up and down from the center in order to find the foci. Okay, so let's talk about how we actually find all of these pieces of information. So one thing about an ellipse equation is you know you have an ellipse when you have an x squared and a y squared. They're the same sign, and you'd have a circle if they were the same number, but they're different numbers. So see this 4x squared and this y squared, same sign, but different numbers. That tells you you're going to have an ellipse. But your strategy is the same basically as solving for a circle where you complete the square twice. So you gather everything together. That's an x. Leave a blank for completing the square. Gather everything together. That's a y. Move the constant to the other side and leave two blanks there. Now, I really should factor out a 4 times x squared minus 2x plus blank. Here we just have y squared plus 4y plus blank equals 8 plus blank plus blank. So how do I complete the square inside here? I need a 1, but really I added 4. How do I know I added 4? This 1 is really multiplied by a 4 in front, so if I add 4 to one side, I have to add 4 to the other side. To complete y squared plus 4y, I need a 4, which means I need a 4 on the other side. There's no multiplier there. So this is 4 times x minus 1 squared plus y plus 2 squared equals 16 when I add everything on the other side. Now I'm supposed to set this equal to 1, so I need to divide everything by 16. So 4 divided by 16 becomes 1/4, so this becomes x minus 1 squared over 4 plus y plus 2 squared just over 16, there's no constant, equals 1. Okay, so this is the formula for an ellipse, but I need to find these pieces of information. So the center is the same thing as center of a circle would be. It's the opposite signs to what you see. So the center for this thing is 1, -2. Okay, so to find the vertex of these things is going to be the endpoints. So how far I can go outside from the center in each side. To find out how far you can go out from the center, in the x direction, I can go the square root of 4 out in the center. The y direction, I can go to the square root of 16 out in the center. So what does that mean? I can go out 4 in either direction in the y direction. So let's talk about my y points, my major axis vertex is when I go up or down 4, because that's bigger than 2 for x. So going up 4 from -2 would be 1, +2. Going down 4 is 1, -6. For minor, I would go 2 to the left and right in the x direction. So it's from 1, -2. So that would be -1, -2, and 3, -2. The foci. To find the foci, I need to take my b squared minus a squared, my bigger one minus my smaller one. So what's 16 minus 4? It's 12. And take the square root of that. The square root of 12 is 2 square roots of 3. I'm going to leave it like that. Can't simplify it. You could get a decimal. And this is how far from the center I go out in the major direction. So I need to go out in the y direction here. So my x is the same as the x value in the center, which is 1. Now I need to do -2 plus 2 root 3 and -2 minus 2 root 3. I'm going to just leave it like that because there's no reason to do anything else. So this is my center, my vertices, and my 2 focuses. So we always 4 vertices, 1 center, 2 foci. Now, to find the eccentricity, the last thing, it says it's the ovalness of the ellipse. It's like how oblong looking the ellipse is. And it's c, which we get c by doing 16 minus 4, divided by the length of the major axis. Now remember, you have to take the square root. So it's the square root of 12 divided by the square root of 16. So c is the square root of 12. The major axis is the length of that 4, the length of the major axis. So that's 2 root 3 over 4, which gets reduced to root 3 over 2. So this is the eccentricity. It should always be between 0 and 1 because these are lengths, so they'll always be positive. B squared minus a squared can't be bigger than b squared because you're subtracting a positive number. So the closer to 1 you get, the closer to a circle it gets. So this is about 0.86. So it's pretty close to a circle. It's not that close, but the closer to 0 you get, the more ridiculous your ellipse looks. Like if this were 1, it would be a very flat circle, and instead this would end up being... actually, I think it's the closer to 0 it gets, it's a circle. I misspoke. The closer to 1 it gets, the more oblong looking it is. You're like, well, what happens when it reaches bigger than 1? It can't get bigger than 1 because once it's bigger than 1, you'd have to be adding a number, and that technically sends us into what's called a hyperbola, because that would require your signs to be opposite, and we'll talk more like that. So again, closer to 0 means it's closer to a circle. Closer to 1, it's more oval. So this thing is pretty close to 1 because if you think about it, it goes out twice as far in one direction as the other, so that's pretty oval-like. I don't know what the word for that would be. Pretty eccentric, I guess. That's the measurement of eccentricity. So it's more eccentric, the more like an oval it looks. The less eccentric, the more bland like a circle it looks. And we'll get into hyperbolas next.